So, loving students of Riju and PSK classes, another session of physics, current electricity. In the beginning, let me ask you, you all have seen cells like this. This is known as a dry cell. There are different sizes, dry cell. And if I see this, there is something written here, 1.5 volt, 1.5 volt it is written. You know, electricity will give you electrocution, that means electric shock. Why don't I get an electric shock even if I touch the two ends like this? I am not getting any shock, I am safe, I am happy. Even if I take two cells like this, I am happy. Okay. But can I do that with this thing? Now, right now, power is off. Power is off. You do not attempt this at your house. Okay. Careful. Disclaimer. What will happen if I could insert my two fingers on a live plug points here? Will I be safe? Will I be smiling again? Okay. Now, one more point. Suppose there is a small table here. If I climb on the table and jump down, I will not die. I won't get hurt. But if I do that with a tall building, climb on the top floor of a 10-story building, and if I jump down, definitely I'll get injured, I may even die. Is there anything common with the small table, the cell, the large building and this thing? Is there anything common? If you can correlate this, then one of the fundamental property of electricity is clear to you already. You don't need me in between. If it is not clear, then listen to my classes. In today's session or maybe tomorrow's session, we will be discussing about all this. Meanwhile, a small recap of what we have been doing in the last class. That was about resistivity and its variation with temperature. I introduced a term, temperature coefficient of resistivity, which we defined as 1 by rho d rho by dt, and at 0 degrees Celsius. See, the definition do not have 0 degrees Celsius. What I mean to say is that 1 by rho d rho by dt can be defined at any temperature. Whatever value given in the NCERT textbook is defined at 0 degrees Celsius. So, if the value of alpha is defined around 0 degrees Celsius, then you have alpha defined as R2 minus R1 by R1 T2 minus R2 T1 can be applied, and this is applicable for any temperature, but generally value of alpha in the textbook is given as 0 degrees Celsius. That is what I say, this equation is around 0 degrees Celsius if you use that value. But many times general questions are not solved like that. General questions we take an average value alpha between two temperatures. Then this equation is sufficient. R2 is R1 times 1 plus alpha T2 minus T1. Then alpha is R2 minus R1 by R1 into T2 minus T1, where R2 and R1 are the value of the resistance at two temperatures, and T1 and T2 are those temperatures. And the temperature should be taken in Celsius, because alpha generally is given as degree Celsius inverse. Based on this, there is one example in the NCERT textbook which reads like this one. This requires a little bit of application of Ohm's law. There is an electric toaster, nichrome wire, small current passes through it, at room temperature 27 degrees Celsius, resistance was 75.3. When the toaster is connected to 230 volt supply, current settles to 2.68. So, you know voltage, you know current, you can find out the new resistance. Initial resistance was 75.3, the new resistance is 2.68. What is the temperature of the nichrome element at that time? What is the temperature? Temperature coefficient of resistance of the nichrome averaged over the temperature range. That means the average value is given here. So, I told you, if an average value is given, then it is always easy to use this equation. Alpha is R2 minus R1 by R1 into T2 minus T1. R1 is given in your question. R2 you can calculate using V by I, Ohm's law. Then you can find out T2 minus T1. What they want the temperature. So, you can write T2 minus T1 in terms of the remaining parameters. Let me try. This is solved in NCERT. So, you can just go through that one. So, here I can write T2 minus T1 equal to T2 minus T1 equal to R2 minus R1 divided by R1 alpha, where alpha is the average value. Now I want T2, so T2 is nothing but T1 plus R2 minus R1 by R1 into alpha. Just to substitute the values, T1 is the initial temperature. Okay, if you want answer in degree Celsius, you can use degree Celsius. If you want answer in Kelvin, you can use that one. So yes, let's do that in degree Celsius. Then if you want, you can convert that into Kelvin. T1 is 27 degrees Celsius plus R2. R2 is calculated. R2 is calculated using this voltage and this current. So that is calculated as V by I. R2 minus R1, R1 is given, the initial value is given as 75.3. See, not that, it is not at 0 degrees Celsius, it is at temperature 27. Okay, R2 minus R1, alpha is given 1.7 into, see the unit, degree Celsius inverse. So just apply this one, get the answer. It's all in the NCERT textbook, just go through the solution. Fine. So most of our questions are done using this equation of average value. Okay. Now, next one. Again another example, resistance of platinum wire of a platinum resistance thermometer. That's important idea. Platinum resistance thermometer at the ice point 0 degrees Celsius is 5 ohm. At the steam point, that is 100 degrees Celsius, 5.23. When the thermometer is inserted in a hot bath, what is the resistance? The resistance of the wire became 5.795. See, it's more than 5.23. That means temperature is more than 100 degrees Celsius. Calculate temperature of the bath. Okay, thermometer idea, you have the in thermometry, you studied that thermometer generally, all thermometers generally has a graph which runs like this. Okay, there will be temperature taken here in some unit and there will be some parameter like length, resistance, pressure, anything or taken here. Here we take a resistance R. Okay, let us say this point represents 0 degrees Celsius, which is your where is it, which is your where is it, ice point. Ice points here, ice point, and say this is 100 degrees Celsius, which is the steam point, and since the resistance is more than at the steam point, I would say the new temperature is somewhere here T. Now at 0 degrees Celsius there is a resistance. Okay, how much is that one? That is given as 5 ohm. At 100 degrees Celsius there is a resistance. How much is that? That is 5.23. At the new temperature there is a resistance and that is given as 5.795, and all of them should lie in a straight line. I mean roughly should be in a straight line. Okay, so there is a point here, there is a point here, there is a point here corresponding to the three values. Now the slope between any 2 points must be the same. So I can actually calculate a slope between, slope calculation, that's what I do, slope calculation. What is slope calculation? See, here I can consider a triangle, then I can calculate slope as 5.23 minus 5 divided by this y2 minus y1 by x2 minus x1, 100 minus 0. The same slope should be there between these 2 points for the large triangle. And what is that one? It is 5.795 minus 5 divided by temperature is T minus 0. Solve it. You can see that you are actually ending at the same equation of average value, R2 minus R1 divided by R1 into T2 minus T1. Same equation, slope calculation. Because only when the graph is a straight line, you can use it as a resistance thermometer. There should be a linear variation. Only then it will become it can be done in a simple equation, mathematical equation. So please work out this question as well to strengthen your idea about this one. Because this kind of questions can be expected in examination. Okay. Right. After that, these are exercises in the NCERT textbook. Please work out them. Same, the idea is same thing, nothing new in that one. So there is a question given. There is a heating element 100 ohm at 27 degrees Celsius, just like the previous question. What is the temperature of the element if the resistance is found to be 117 ohm? more than 100, so temperature should be more than 27. The temperature coefficient of the material is given as 1.7. This must be an average value because they did not mention the temperature. They did not mention at what temperature it is, so you should take it as an average value. Just go for the equation alpha is R1 minus R by R into T1 minus T. Same thing, R2 minus R1 or R1 minus R, apply that one, you'll get either 1027 degrees Celsius. Work out this at home. Fine. There is one more question. A silver wire, resistance 2.1 ohm at 27.5 degrees Celsius and resistance 2.7 at 100 degrees Celsius. 2.1 to 2.7, so there is an increase in the resistance. Again go for the same equation, alpha R2 minus R1 by R1 into T2 minus T1, and you will get this as 0.0039 degrees Celsius inverse. There was one more equation which was, I told you, which was found around a particular temperature, okay, and that equation was, it was R2 minus R1 for alpha divided by R1 T2 minus R2 T1. I told you this is around a particular temperature, not an average value. So if you use this equation in this case, I think you will get the answer approximately 0.0043 degrees Celsius inverse, approximately. That's what I remember. And you can see these two values are very close. So whether you go for that one or this one, your answer will not be much different. But always use a wise selection depending on the options given. There can be some questions which can give you trivial answers. Okay, it's up to your luck to get the proper option in the examination. Because unless they mention the condition, it's possible to use any of these equations. In this case, I can use any of that one because they did not say anything in particular. Okay, but generally, if the temperature is not mentioned with respect to this alpha, I can go for this method, this method, not the other one. Fine. So I say, in most of the questions, you can directly go for this equation. Very rare cases, you have to worry about this thing. And for IIT-JEE examination, definitely the equation alpha equal to 1 by rho d rho by dt should be clearly studied, because this will end up in an integration, because these are all differential changes. Okay, that's it. Now, there is one more example, exercise, exactly like the example given in the NCERT textbook. See, heating element, current, voltage, everything is given, averaged over, alpha is averaged over. So we can go for that. And what to be calculated? What is the steady temperature of the heating element? So what to do? You can directly go for this equation. That equation is T2 equal to T1 plus R2 minus R1 by R1 into alpha. This is the equation that we can use. Again, an averaged value. Fine. So that's all about this area. Sometimes become confusing. So practice very well and make your ideas clear. Okay. Now we have a superstar of all conductors, God of all conductors, the king of all conductors, not God, king of all conductors. It's called a superconductor. Superconductor, we know every conductor has got some resistance. Superconductor is a material which will lose all resistances at a particular temperature. A material with a zero resistance. It can have amazing end results as far as engineering and technology is considered. If you can make a superconductor, then you can have very tiny motors which are very powerful. You can have very fast moving vehicles which will take only very small amount of energy for their operation. So all things can become beautiful in the world if you can have superconductivity at room temperature. But the problem is this, mercury behaves like a superconductor at 4.2 Kelvin, shivering temperature, minus 270. Fine. The phenomenon of losing all resistance when cooled below certain temperature is known as superconductivity. Superconductivity is a phenomenon associated with the materials where when you cool them from room temperature downward like this up to 0 Kelvin. Okay. Normally, non-superconductive material, their resistivity decreases. but it will not become 0 at 0 Kelvin. Temperature is 0 Kelvin, but the resistivity is not 0. But for superconductor, what happens? When you cool them, they will follow a curve like this. But at this particular point, what happens? Suddenly the resistivity becomes 0 at a particular temperature. This is called the critical temperature. Tc is the critical temperature. What is critical temperature? The temperature at which a material loses all its resistivity or all its resistance. And for mercury, it is 4.2 Kelvin. In one paper in CBSE, they gave you a question about this graph. Okay. Nothing more to study about this one. Definition, the graph. This is the graph of superconductor. And just memorize, mercury behaves like a superconductor at a very low temperature of 4.2 Kelvin. Fine. Later in another chapter, magnetism, you will see another phase of superconductor. Another amazing phase which will enable you to build levitating magnetic train, super fast magnetic trains. There are a lot of videos about that effect in the YouTube, superconductor. Just Google, you will see that. Okay. That's about superconductivity. Okay. I am discussing this question due to demand, because many people wanted me to discuss this particular question, which is actually based on a 10th standard level. Resistance of a wire is 20 ohm. The wire is stretched to 3 times its length. The resistance will now be, what will be the new resistance? There is an equation for this kind of stretching. You are stretching a wire. When you stretch a wire, the new resistance will be equal to n square the old resistance. What is n? N is a number of times you are stretching it, and that n is given here, and that is equal to 3. So the answer should be equal to 3 square 9 into the original 20 should be 180 ohm. This is the answer. But how and why? Okay. The reason, suppose you have a wire, area of cross section A, length L. Then we know its volume is given by A into L. When you stretch that to a certain number of times, what will happen? The wire will become thin, its length will increase, area of cross section will decrease. So this area will become A dash, the length has become N times L. The volume is the same again, volume will not change. We discussed in the last class also, the volume is nothing but N into L into A dash. So comparing the two volume, you can see A dash N L equal to A into L. You will see A dash is equal to A divided by N. So if you stretch it 3 times, the area will become 3 times smaller. So what is the equation for the resistance in the beginning? That was rho into L by A. Rho will not change because the material will not change. See, there can be small changes in rho due to change in temperature, but that is neglected. So what is the new resistance R dash? R dash is equal to, the rho remains same, L became NL, A became A by N. So this gives you N square into rho into L by A, which is nothing but N square into R. That's it. So I did one question in the previous class. Now I am doing that again so that you can be sure about that one. Okay. Right? But there can be another variation. Listen carefully. See, this is stretched, that's important. Okay. Assume that you have a wire, so my presentation, no, I should see the other presentation. What is happening? Okay. Sometimes technology is not good. Fine. Suppose that you have a wire whose length is L, area is A. Suppose that its resistance is R. What is the resistance of a similar wire with 3 times the length? Similar wire means same material, same area of cross section. If I take another wire of length NL with the same area, what will be its resistance? Here it is not N square times, R dash is nothing but, see, area remains same, length increases. So we know R is given by rho into L by A. What are the terms constant here? Rho is same for both of them. A is also same for both of them. So R proportion to L. So we can say R dash is simply N times L. So you do not confuse. Read this question always. If it is stretched 2-3 times, then there is N square R. If it is not, it's N into L. Resistance of a wire is proportional to length. Okay, tell me, when is this condition applicable? ഇത് എപ്പോഴാണ് applicable ആവുന്നത്? If you know it, if you are okay with that one, by the end of the chapter we will be discussing 2 important laboratory instruments where we use this principle. In the laboratory you have to do this for your practical examination. So if you can simply understand this concept, those 2 examples, those 2 experiments will become very easy for you. Watch out. Where is this applicable? When the material and the cross-sectional area are the same, then resistance is directly proportional to the length. For example, if I take a wire of this size, say this much, resistance 10 ohm, what will happen if I take a double fold like this? Then that will become 20 ohm. What will happen if I take 4 times that one? That will become 40 ohm. Resistance is directly proportional to length only when area and the material remains the same. Is that okay? Fine. So I guess this is easy. Now this question, hollow copper tube, there is a diagram. Its length is given as 5 meter. Its diameter specifications are given. The length is 5 meter. External diameter is given as 0.1 meter. Okay. And the walls are 5 millimeter thick. This wall is 5 millimeter, means 5 millimeter, 5 by 100, 0.05 meter thick, 0.05 meter thick. The specific resistance of copper is given. Calculate the resistance. So how do we calculate resistance of a conductor? It is rho into L by A. What is rho given? Rho is given as 1.7 into 10 to the power minus 8 into length is 5 by. What is the area of cross section? Which area are you talking about? You are talking about this area. This is the area that you want. And how do you calculate that one? It's like outside area minus inside area, because if you see the cross section, this is a circle, this is the inner circle, you want only this area. You want only this area. This area can be calculated if you know the outer diameter, that is pi into d outer square by 4 minus, if you know the inner area di, this is do, then that is pi di square by 4. Since pi by 4 is constant, you can write like this. You can take that as constant. So you can say pi by 4 into d out square minus di square. Fine. And how to find d in? How to find d in? This is thickness, this is thickness, this is also thickness. So we can say, you can say that d inside is nothing but d outside minus 2 times the thickness. And d outside as per the problem is 0.1 minus 0.1. So that is it, 0.1 meter, because 5 millimeter and 5 millimeter gives you 1 centimeter difference in that one. Fine. So then you can work out. Fine. So just work out and get the answer. Okay. From there, another beautiful question. In order to increase the resistance of a given wire of uniform cross section to 4 times its value, a fraction of its length is stretched uniformly till the full length of the wire becomes 3 by 2 times the original length. What is the value of this fraction? Okay. In order to increase the resistance of a given wire of uniform cross section, there was a wire of uniform cross section, okay, and you need to increase that to 4 times. That means you want to make a r to 4r. You should increase it to 4 times. A fraction of its length is stretched, not the complete length, only a fraction is stretched. Suppose the wire is this much, then only a small fraction is stretched, the remaining fraction is same, unaltered. What should be that fraction? And the new length, the total length is 3/2 times the original length. Suppose the original length was L, the new length is 1.5 L. And are you stretching the complete length of this one? No, you are stretching only a part called x. So what is that part? X by L. This is what asked is. For example, you have this diagram where the wire is L. You elongate this to 1.5 L, not by completely stretching, but by stretching a small part. Like you take a small section here, then you stretch that one. So the other section will remain like this, and this section will get stretched. This is the concept of this problem. Okay. So let us do this. Let us do this. I think I can go for pre-planned diagrams here. This is the wait. This is the original wire. The original wire has a resistance R, which is equal to rho into L divided by A. You can see A is the area of cross section, L is the length, R equal to rho into L by A. Now this wire is considered as a section L minus X and another section X, and this section is going to be elongated, stretched. In the second diagram you can say L minus X section remains like that, but this one increases so that the total length is 1.5 L. You can see this is the total new length. This is 1.5 L. Okay. Now the whole length is 1 L. This is L. So if you compare that here, you can see this is the old wire, this is the new wire. If you compare that one, this is extra. This is extra 0.5 L. That is extra 0.5 L. Now compare that with this diagram. This was X, and you elongated that to X plus 0.5 L. Okay, X plus 0.5 L. So what should I say? I must say that this was the original wire. This portion X was stretched to how much? 0.5 L plus X. The elongation is 0.5 L plus X. Now you can see this part has a resistance, that part also has a resistance. If I call this resistance as R1 and this as R2, this portion as R2, how to find R1? R1 is nothing but rho into L minus X divided by A. Area is same. What is R2? R2 is that part. Its length, its rho is same. Its length is 0.5 L plus X divided by its area is A dash. Its area is A dash because area decreased. Okay. Now how to find this A dash? You should know that volume of this portion. What was the volume of that portion? Its volume was A into X. And the volume of this portion must be the same. What is the volume of new portion? That is A dash into 0.5 L plus X. So that gives me A dash is equal to A into X divided by 0.5 L plus X. So you have to substitute this in this case. So take this value and substitute here and calculate. I think the calculation part I am leaving to you because you need to practice all these things. This will end up in a complex equation which you can solve, and you will get x equal to 1 by 8. Try x equal to 1 by 8. Fine. Work out these questions. Do not wait for the teacher's answer for this kind of questions because these are all direct questions. We have more complex questions coming. So study, work out, get the correct answer. Thank you. See you in the next class.